Amazing, amazing. Pasi, you're happy as well? Okay, thank you so much. So we're now going to transition to our last session of today. Quite an interesting one. It's going to be different. It's not going to be a panel discussion, but it will be a presentation, an in-depth presentation on unlocking hydrocarbon potential, looking at the Lake Kivu Basin. And the presenter is Dr. Youssef Ahmed Mohamed, oil and gas expert with RMB. So please, let's welcome him as he comes to take us through this detailed presentation. There he is. Yes, please, let's give him a big round of applause. As a matter of fact, let's escort him up until he takes his place here. Let's continue with the hand clap and give him the energy needed.
Ramuse, hello everybody. I'm going to take you from the solid mining to liquid and gas mining. And this is about the hydrocarbon potential of Lake Kivu Basin, and exploration and production opportunity. So as we know, Lake Kivu is part of the East Africa Rift System, which makes all the lakes in East Africa, including Albert Lake, Kivu, Tanganyika, Malawi, and others. Also, it is part of the what we call Albertine Graben. This is square, black square. This is structurally the same between Albert Lake and Kivu Lake. The Lake Kivu Basin is analogous to Lake Albert and Lancashire Rift Basin, and also to other rift basins in Africa. They are similar in geology, they are similar in structure, and hopefully they are similar in hydrocarbon accumulations. The commercial discoveries in Albertine and Lancashire rift basins represent a breakthrough in exploration and also highlight the exploration potential of Lake Kivu Basin. As we know, now in Albert fields, commercial oil field discovered, they are building a huge pipeline, a very long pipeline from Albert Lake all the way through Tanzania to the Indian Ocean. And this pipeline is going to be commercial, operational next year. Lake Kivu Basin is a half graben. This is the shape of half graben, if you can see. This is a seismic line in Lake Kivu, over Lake Kivu Basin. The fault you can see, this big fault, which we call it West Kivu boundary normal fault, and to the west of that fault is what we know as Ijwi Island, the famous big island in the middle of the lake. The structure is similar to the Albertine, Lancashire, and other rift basins in the region, including the famous Mughlet Basin in Sudan. It's the same structure you can find, and we will see that in more details. There are two seismic lines here. The one on the left side is interpreted seismic line from Mughlet Basin, and the left side is a seismic line over Lake Kivu Basin. We can see that the structure is the same, geologically, tectonically the same, and the black circles in the left seismic line, the black dotted circle, is where they discover oil. The same structures you can find in the Lake Kivu Basin, similar structures. So they have similar tectonic setting and depositional environment to prolific rift basins. This means that there is a potential, very high potential in Lake Kivu Basin. If we compare what we call the elements of the petroleum system with other non-rift basins to Lake Kivu Basin, then we can say the source rock, the certainty is confirmed in Albertine Basin, it's confirmed in South Lancashire Basin, and it's confirmed in the Muglet Basin. And geophysics data, which is the seismic, proves the presence of alternating sandstone and shale. And so it's projected to be present in Lake Kivu Basin based on the data already acquired. The quality of the organic matter in the source rock, in Albertine Basin, and in South Lancashire Rift Basin, and in the Muglet Basin, they are all what we call good source rock. And in Lake Kivu Basin, since it is a lacustrine, it's deposited in a lake. It's not the present lake, by the way. It's a lake that was present probably 20 or 30 million years ago. Not the present lake. So it's the same depositional environment, so we expect the source rock to be the same quality. The hydrocarbon, it is discovered, commercial hydrocarbon by the way, discovered in Albertine Rift Basin in Uganda, and in Lancashire Rift Basin in Kenya, and in the Muglet Basin in Sudan and South Sudan. In Lake Kivu Basin, the high geothermal gradient, it will mature the source rock, and it will generate hydrocarbons from this maturation. The reservoir quantity, or quality, the porosity and permeability, it's good, fair to good in all the three confirmed basins, as we said for the source rock, the same environment and the same petrophysics. The trapping of the rift basins, in all rift basins in the world, the trapping is mostly structural trapping. We will see that in the coming slides. So normal faults and rollover faults in Albertine and in South Lancashire and Muglet Basin, the same faults are present. I'm going to show you in the coming slides, and the rollover also faults are there. So the basins have similar lacustrine deposition environment and tectonic rifting mechanism. And these basins are confirmed to have oil, discovered commercial quantities. So this is why Lake Kivu, it has a potential to discover commercial quantities of oil. The good thing about the Rwanda Lake Kivu Basin is that the R&B, they acquired some data. So any investor who is coming, there is a data for him to build on. He's not going to start from scratch. And this data will help him to guide him to do more exploration, to acquire more data, and to help him do his exploration work. So there is a marine gravity and magnetic. This is the volume, which is about 3,000 kilometers. This is the marine gravity and magnetic prove that there's a basin which is about 5 kilometers deep. The thickness of the sediments is about 5 kilometers. The seismic reflection, which was acquired in 2012, there are almost 500 kilometers of single channel and multi-channel lines. And this data prove the existence of 4 distinct sedimentary sequences, and as I said, half graben basin, and the presence of structural traps. The 2D seismic, which was acquired in 2021, is about 450 kilometers in size. It also confirmed the presence of structural traps, the half graben basin, and also confirmed the presence of 12 leads map. Leads where you can add some more data to upgrade to prospects so that you can drill for hydrocarbon. And there's one prospect that I can name it as a prospect because it has been confirmed by so many seismic lines. The geochemical analysis done for core samples and gas chromatography and the isotopes, they prove the presence of thermogenic hydrocarbons. As we know, in Lake Kivu now, there is a methane gas which is present at the bottom water of the lake. This methane gas, the origin of the methane gas is controversial, or the scientists are not really know what is the origin of the gas. Maybe it's biogenic, most people say like that. Maybe it's a mixture. Personally, I think it's a mixture of origins because we discovered the chemical analysis shows or prove the presence of thermogenic hydrocarbons. These are heavier gases which are ethane, butane, pentane, okay, the C3, C4, C5 hydrocarbons, and these are usually thermogenic. This means that it is due to the maturation of the organic matter. It's not a biogenic. Biogenic is a bacteria thing. As we said, on the right-hand side, the Lake Kivu Basin, according to the gravity, can be divided into 3 major subbasins, according to the depth of sediments. Don't think this is the current lake. This is the 20 years ago 20 million years ago. We are looking at this thing, okay? So it's over the same lake, which is, but the history here we are telling, it happened about 20 million years ago, not now. So we can divide the basin into 3 sub-basins according to the depth. The one in the north sub-basin, which is very deep, not the water depth, the sediments thickness, okay? And the central sub-basin and the southern sub-basin. And the southern sub-basin is probably middle of this big island. On that left-hand side slide, there's a reddish square which shows the area where the 2D seismic was acquired. You can see that most of the southern part, the central and southern part, no data is acquired. Okay? But also it shows the thickness of the sediments, as we said, is about 5 kilometers. And this map is based on gravity. It's a Bouguer anomaly gravity, which tells you the top of the basement. The top of the basement in the deepest part is about 5 kilometers, which is the dark blue color. Okay. Top of the basement from the seismic, we cannot pick, we cannot see. It's not clear because, I think because due to acquisition and processing parameters. The chosen parameters are not the correct parameters. So the coming investor, when he comes, he will see what parameters used in this survey, seismic survey, and I'm sure they will change it to enhance the quality of the seismic so that they can see the top of the basement. As we can see here on the right-hand side, there is a yellow line, which is the bottom mappable reflector. This is what we can see. Below this, we cannot see anything. It's something you cannot tell. So there is a possibility that the basin is thicker than this. That line, it shows also the same thing. This is a 2D line acquired in 2021, and that one acquired in 2012. The hydrocarbon elements in Lake Kivu Rift Basin, or the presence of the hydrocarbon elements in Lake Kivu Basin, the structural traps, they are confirmed by by the normal faults. You can see on, I don't know, okay. Can you see this red, this greenish, okay? This here, it's a faulted anticline. Anticline means like this, okay? And this is where the oil is trapped. The big elephant oil fields, size, big fields are discovered in such structures. This is a faulted anticline. These lines are faults, normal faults, okay? The same thing here. This is a normal fault. This is structure, and this is structure where we can find oil in all rift basins around the world, not only in Rwanda. Every rift basin, normal fault structures or structures created by normal faulting, this is the thing that if there's oil you can find. The structure is already there to trap. This is also another type of structure, okay, which is we call a rollover fault, which is against the basement. The sediments are rolled over against the basement. So this is here the basement rock, which is not porous, not permeable, and here is the sediments. And if there is oil going through to migrate, this is the arrows showing the migration. It's going to migrate, then it cannot go through because here it's a solid rock. There's no porosity, no permeability. So it's going to be trapped in here. Here is going to be trapped, and here is going to be trapped, the same. So all this shows that the real potential in Lake Kivu Basin. And it's not only academic comparison, but this is a comparison based on data, real data, acquired data. So the hydrocarbon elements in Lake Kivu Basin, the structural trap we just discussed, they are present. The seismic data confirm the presence of the structural traps in Lake Kivu Rift Basin, the maturity of source rock, the lacustrine depositional environment, high TOC. TOC is total organic carbon because this is deposited in deep water in lake, and usually it has a high total organic carbon. And type 1 to type 2 kerosene, which produces oil, mostly liquid oil, and gas, fuel gas. The high geothermal gradient coming from where you know the rift, this is all East Africa Rift Basin, is very hot below. 3, 4, 5 kilometers below is very hot. This is why you have volcanoes in near Goma, volcano just last month was in near Ethiopia. This is all because the earth below is very hot. And this heat make a high geothermal gradient. It will cook any source rock, any organic matter is going to be cooked and to generate oil. And also, as I said, there's the presence of thermogenic hydrocarbons has been recorded by the geochemical analysis. The reservoir rock and the play type, it's lacustrine fan delta deposits and alluvial fan delta sandstone with good porosity and permeability. So the high potentiality of discovering hydrocarbon in Lake Kivu Basin. The origin of methane gas in bottom water is a mixture of biogenic and thermogenic. I put a question mark because this is still nobody, most people say it's biogenic due to bacteria, but there's no such big evidence. It could be a mixture of origin. And by the way, CO2, which is carbon dioxide, which is present in the Lake Kivu Basin water also, has been discovered in Albertine Basin and in the Muglet Basin. In Albertine Basin, I know they drill a well. It produces only CO2. Nothing. No methane, no oil, nothing. It's only CO2. And they drill, it's not in the water. It's in the sediments. Probably it's about 1,500 meters deep, or maybe 2,000 meters deep, but it's only CO2. In the Muglet Basin, where my most of experience is, we usually have CO2 produced with the oil, coming with the oil. Not big quantities, but we have it. This indicates that CO2, it can be present even at subsurface. And CO2 may be present because very deep organic matter is overcooked. Overcooked. If you overcook any organic matter, CO2 is going to be produced. So CO2, some people, they say it's coming from magmatic origin, which is overcooking also. Okay, now we talk about the structural traps. This is a line, this is where the line is. The green here. This is, by the way, here is this big island, Ijwi Island, in this area. So this line was acquired in 2021, I believe, seismic line. This is close to Ijwi Island. The boundary between the two countries is somewhere here. So we can see that the rollover against the main basin bounding fault, the rollover structure, you can see here, it's because of this here, the rock is impermeable. It's a solid rock, basement rock. So the oil, if there's any oil, is going to be trapped here. And here, the normal faulting, which we call it step-up structural faults, you can see here is one set, here is one set, and here is one set. So if you discover oil here, you can discover oil here, you can discover oil here, depending on how much oil is being generated from the kitchen area, which is the cooking area. These are proposed drill locations. Okay, I'm sure that an oil company, when they come, they will not blindly come and drill here, but they will do some work before they can decide where to put their well. The force system controls the formation of traps, as we can see. This is here is making the rollover against the basement, and here is making the displacement of porous rock against impermeable shale rock. So here the horizontal seal here is, I'm sorry, the horizontal seal here is impermeable shale, clay stone. The horizontal, you know. The vertical is a trap, is also the cap rock, which is a shale. Here the horizontal seal is the solid basement rock, like granite or whatever, okay? This is another seismic line, which indicates a very interesting structure, which is this domal structure, or we call it anticline structure. This line goes, sorry. I have to go back. No. Yeah. Okay. This line here is a long line. Okay. From the north to the south. This is Ijwi Island in this area. Okay. You can see this is this anticlinal shape. Okay. Present very clear in this seismic line. And this anticlinal shape are favorable structure for oil accumulation. Okay, so this is one of the structure traps. The other one, as we said, is the fault. The faulted anticlinal trap, which is this one. it's a fault anticline trap. This means that there's a fault here, a fault there. So this is also a favorable structural trap. And this is the seismic line. It's here, and this is the line. This is what we call prospect C, one of the mapped prospects. It's a big prospect shown by this line. Okay. Here we map it. This is the map of the prospect. This is the major fault which is bounding Ijwi Island from Lake Kivu Basin. We can see that this fault, this is a decline structure, like a domal structure, same present here. Okay, so this is what we call a prospect C. It's not a lead, it's a prospect. The geologists know the difference between the two terms. This line is line number 31. Okay, also, maybe there's a presence of stratigraphic traps. Maybe. Stratigraphic traps mean that there is a change in lithology when you go horizontally from one place to another place. Then there is a change in lithology from sand to silt to clay. This will make stratigraphic trap, and this line is line 22, which shows these structures here, these reflectors, which may indicate the stratigraphic traps. And here also you can see the fault against the basement, the rollover structure. This is another seismic line. It showed the structure, and it also shows something we call DHI. DHI is direct hydrocarbon indicator. When you have this, it's almost you are 100% there is oil. What is DHI? DHI is a straight line, as if you draw it by a ruler, very straight. Here, unless you have a very strong eye, it's difficult to see. But you can see here, this line here, very faint grayish line, is very straight. It's not like these lines. These lines goes up and down. Okay? But here, this is a very straight line, which we call direct hydrocarbon indicators. And this is a very strong evidence that if it is really a DHI, oil is there, hydrocarbon is there. I put a question mark because it's not very clear. It needs a very strong eye. My eye is strong, I know it, but but others maybe, anyway, I put this question mark so that it can be discussed. The good thing about this here what we call the kitchen area. The kitchen area where the organic matter is cooked, mature, and the oil is generated, and it goes up, migrate to the structure. Whenever there is a favorable structure, it's going to be trapped. So there is a high geothermal gradient, as we said, because of the nature of the East Africa rift system. It has a high geothermal gradient. So any source rock here, it can be mature and it can generate hydrocarbons. These are the mapped leads and the prospects. As we say that, there are 13 leads have been mapped. All of them are structural traps. And there's one prospect, I call it a prospect, this one, which is prospect C, because it has been defined by more than 5 lines, more than 5 seismic lines. So this data is a very encouraging data for investors. Because when you tell investors that you already have data and this data is being interpreted, then this will encourage them to come. Of course, they are going to load the data by themselves, and the geoscientists was going to be to interpret the data, whether they agree with my interpretation or don't agree, but at the end, there's the data that they can build their model based on the data. These are the lines, you know, these blue lines. This is the line, this is the seismic acquired, the 400 something kilometers acquired. As we can see here, you go down. This is the central part of the basin. So all the way down up to the Rusizi River outlet, there's no data. So here is more slides showing the leads that have been mapped. This is what we call lead A and B. It's also a faulted anticline structure, which is a domal structure. You can see here. It goes up, and then it goes down here. And there are normal faults here. So these are the mapped, this is the map for an oil company. If I am an oil company coming to invest, I will shoot a seismic line here, additional, what we call infill line. Infill line here, and another line from north to south here. Then I will confirm the presence of this structure. If it is confirmed, then it's going to be a drillable location. Okay, now this is the prospect C, which is the most important mapped structure based on the data. Okay, you can see this prospect C, you can see the number of seismic lines that cross this structure. This is 1, 2, 3, 4, and there's another one here, 5 and 6 on this side. So it's quietly defined by seismic lines, and the structure we can see here is a faulted anticline structure. This structure, if we go back very quickly, let me see. No. Yeah, this structure is the same. This seismic line was acquired in 2012. It's the same structure, same, okay? And the other seismic, which is the 2D seismic, which is acquired in 2021, it confirmed the presence of the structure. You can see, it's an anticline structure, faulted anticline structure. This is the same reflected, the green one here, and it's the same here. It goes up like this, it goes up like this, then it comes down. So any hydrocarbon coming from the kitchen area is going to be trapped here. So this is a very good area or map to look at by investors. And I am sure this will, one of the things that will attract investors. To conclude, we see the similarities between East African rift basins, namely Albert Basin in Uganda, Lake Kivu and Lake Kivu Basin, and the other basins in Kenya and in Sudan. The acquired data indicates the presence of key elements for exploration. The success in Albert Rift and other basins support the potentiality of Lake Kivu Rift Basin, and also any hydrocarbon is going to be discovered in Lake Kivu Basin, there is an added value because there is an existing pipeline already existing. So there's no, the investors are sure that they can pump their oil to the international market. But if imagine that there's no line, this East Africa line, which is coming from Albert Basin to the Indian Ocean, if it does not exist, then if oil is discovered in Lake Kivu and you want to export, you have to build a pipeline all the way from Lake Kivu to the Indian Ocean. And that's a huge investment. So as I said, the pipelines already exist, and any oil discovered in Lake Kivu Basin is going to be, it's easy to send it to the market. The gravity and the seismic data proved the presence of thick lacustrine sediments. Lacustrine means lake. They are deposited in a lake. As I said, this present Lake Kivu is present, but 20 million years ago, in the same area, there was a lake. Okay? And the sediments, they are thickness up to 5 kilometers. The geochemical analysis proved the presence of hydrocarbons of geothermal origin. And this is a very strong evidence, by the way, that the geochemical analysis proved the presence of geothermal hydrocarbons. Number 4, the origin of the methane gas dissolved in the bottom water may be a mixture of biogenic and thermal. Because some people, they say that's 100% biogenic, but I think it can be a mixture of both. The acquired data and the commercial discoveries in the Albert Basin prove the high hydrocarbon potential of Lake Kivu Basin, and this needs to be unlocked. And this is an opportunity for oil companies to unlock the hydrocarbons of Lake Kivu Basin. I am going to quote our CEO, what she declared or mentioned, that, quote, "I extend special invitation to investors interested in the upstream petroleum. The Lake Kivu Basin represents not only an exciting exploration frontier, but also a gateway to sustainable partnerships and shared prosperity." Alice Uwase, CEO, RMP. For more information, this is an email you can contact, and thank you very much.
Thank you so much, Dr. Youssef. Before he leaves, do we have any questions for him on the detailed presentation he shared? There is one question right at the back. If we could have the gentleman, if you could kindly stand.
Thank you for the presentation. I just wanted to ask, with Rwanda having only one lake, which people so love and visit, and the ecosystem that is around the lake, do you think we are currently at a stage where, I mean, that's why we talk about greener future too. Do you think we are currently at a stage where there is enough improvement to actually protect ecosystem as far as hydrocarbons are concerned? Because we know how extracting hydrocarbons, especially at areas where water is concerned, has damaged the environment and everything around it, few kilometer radius as well. Thank you.
Well, what you said is not 100% correct, because there is oil exploration and production all over the world, except accidents. An accident can happen even if you are walking on the street, you can have an accident. So we cannot base our policies and strategies based on accidents, okay? The oil exploration, they follow strictly the environmental laws and regulations. Strictly, I say. Because any damage to the environment, they are going to face financial consequences and legal consequences. This is number one. Oil companies, each oil company, they have specialists in environment, in protection of environment. So the exploration is done in a way that to protect the ecosystem and to protect the flora and fauna of the lake and the area. So in that sense, I think the oil companies are capable of doing their exploration without negatively affecting the environment of the lake. Now you have Albert Lake. There is a big exploration, big discovery there. You have all the West Africa shore, Atlantic Ocean, full of oil fields discovered. There was no accident of pollution. You have in Tanzania now and in Mozambique, along the coast, eastern coast of the of Africa, also no incidents of pollution. You have in the Red Sea, in Egypt, there's a production since maybe 40 years ago in that area. You have the Mediterranean, you have the Gulf of Mexico, big oil companies working there. There was an accident in the Gulf of Mexico, if you remember, when they are doing testing in one of the wells, there was a fault, then there was a spill. That was Phillips, I believe, oil company. And Texas people, they paid a fine of billions, I don't remember the figure, but that was an accident. It's not because their operation is wrong. That was an accident, which can happen, I said, accident can happen. But in general, the oil companies, when they come, they sign a paper that they strictly comply with the regulations of environment in the country. Thank you. I hope this has answered your question.
Thank you. Please, let's appreciate Dr. Youssef for this amazing work. Thank you so much for your in-depth presentation. That was the last session for day 2 of Rwanda Mining Week 2025, and it wraps up everything that we had planned for today. But I want to encourage you, we still have more planned out throughout the week, tomorrow as well as Friday. If we could turn our attention to the screen, the team is going to project a link for different activities that we have tomorrow. And you can look at the link and be able to register. And also you can visit the RAB website looking at the program. There is a clear detailed program on what will be happening tomorrow and Friday. You can look through it, select areas and what you'd want to be part of. And you can also approach the team for any guidance that you may need. So tomorrow set off is 9 a.m. at RDB offices, which is in Gishushu. That's where also the RMB offices are based. So we all meet there at 9 a.m. If the team could kindly project the registration link. Okay, amazing. So we meet there tomorrow and then we'll set off together and begin with the day's activity. As Patrick did highlight, there are fun activities that are planned out. We get to visit also the University of Rwanda, get to see firsthand what everything that has been discussed here. We get to experience the graduation as well as Friday. And we do encourage all of us to be part of it, to participate in that. So that said, thank you so much for your attention. Thank you for being with us throughout today. See you all tomorrow as we continue driving the sector forward. Thank you. But as we walk out, the team will be projecting, and in case we are not able to project it, please feel free to reach out to any person here. The protocol team, they'll be able to guide you. You can also visit the RMB website. All details are there. Thank you all. We do have networking, so please feel free, visit the exhibition, interact with the exhibitors, get to see the innovation that we have there. And yeah, see you all tomorrow. There is the link, there is the link. Where is, okay, so how do we access that? Okay, the team is finalizing on make sure that we get the information. Let's give them about 1 minute to make sure that everything is in order.